Second question suggests that find the coefficient of x square in the expansion of 2x minus 5 times by square root of 4 minus x. Here you have to figure out a expansion up to the coefficient of x square. So you will consider the first binomial theorem first, that is 1 plus x whole raised to the power of n, that we discussed in AS while having a discussion about P1. So 1 plus n of x plus n times n minus 1 times by x square over 2 factorial plus so on. I have to end my discussion, I have to end my expansion up to x square. So that's why I'm going to end my work over here up to the x square. So that's why I'm not expanding it more, because of just x square. Anyways, now I have to work for that is x minus 4 whole to the power 4 minus x whole to the power 1 by 2. So I will expand it separately first, and that becomes square root of 4 minus x could be written as 4 minus x whole to the power 1 half, because square root value is 1 half obviously. So that becomes, I have to take 1 over here in order to apply the standard form. So I will take 4 common from it. Once I take 4 common from it, it will become 4 would be taken as common, 1 minus x by 4 and whole to the power 1 half. Now I will expand this brackets so that I can open in a specific form. That would be written as 4 to the power 1 half and 1 minus x by 4 to the power 1 half. It becomes 4 under root is basically 2, and that could be written as 1 minus x by 4 1 half. I will open this thing by using the binomial theorem, and it could be written as, so 2 times of 1 minus x by 4 raised to the power 1 half could be written as, 2 would be taken as it is because that remains as it is. So expansion of 1 minus x by 4 whole to the power 1 by 2 could be opened by using the expansion of equation number 1. So I can write it as 1 plus, according to that equation number 1, 1 by 2 times pi minus x by 4 plus 1 by 2 times pi, let me write at the bottom, it's giving me not much space, hold a minute, yeah, that's fine now. Okay, 2 times of 1 minus x by 4 to the power 1 half could be written as, 2 remain as it is, 1 plus 1 by 2 times pi minus x by 4 plus 1 by 2 times pi 1 by 2 minus 1 times pi 1 by 2 minus 1 times pi minus x by 4 whole square and whole dividing by 2 factorial, bracket close. It becomes 2 times of 1 minus x by 8, because 4 times 2 is 8, plus 1 by 2, 1 by 2 minus 1 is 1 by 2 times by x square by 8, that will become obviously x square by 128, yes, 128, plus so on. That gives me 2 minus x by 4. Once I multiply 2 inside, so 2 times 1 is 2, 2 times of x by 8 is x by 4 obviously. So 2 minus x by 8 plus, this is minus, so it would be treated as minus, not plus, because of multiplication with this minus. So it would become minus, and minus of x square by 64 plus so on. I have to work my coefficients up to the expansion of x square, so it will retain as it is. This is the expansion for 1 minus x by 4 to the power 1 half. So let me highlight this thing. Now I am going to multiply it with 2x minus 5, because up to this point I just open 4 minus x whole raised to the power 1 half. That is the binomial expansion. Now I have to also multiply it with 2x minus 5 because there is also a product of that. So you will do 2x minus 5 times by the expansion that you did over here, and what it is? It is 2 minus x by 4, 2 minus x by 4 minus x square by 64. So let's multiply together and you are able to get 2 times 2 is 4. So it would be 4 of x minus other one is x square by 2 plus 5x square by 64. You will not consider that thing. Now the question arises, why? Because you have to find the coefficient of x square, not for the x. So you will ignore every term other than x square. So these are the terms that I am getting: minus x square by 2 plus 5x square by 64. Once I solve it by taking the LCM, I am getting minus 27 by 64. So that will be the answer for it. The coefficient of x square is minus 27 by 64. I hope so I meant it clear. Next is B part. State the set of values of x for which the expansion of A part is valid. In the AS we were talking about the discriminant method, that was b square minus 4ac. If b square minus 4ac is less than equals to 0, then our numbers seems to be complex one. That method will also be considered in order to find the values of x, and you can also use another method through which you can find the values, just like that is the expansion 4 minus x whole under root. So you have to work for it. 4 minus x whole under root will be valid for which values of x? So you can write 4 minus x is equals to 0. Just take a square on both sides, that will get rid of that square root, and you are able to get x is equals to plus minus of, you can say it would be shifted over here, so plus minus of 4. Also you can write mod of x is less than 4, and mod of x is less than 4 could also be written as minus 4 is less than x and x is less than plus 4. It means that these are the boundaries of x for which your answer for square root is valid. So once your square root answer is greater than equals to 0 for these values of x, then alternatively your answer for the E part is valid. If it's not coming as if it's coming as less than 0, it means that you are moving towards complex numbers. So complex numbers are basically the imaginary numbers that have no you can say existence inside the real world. So once discriminant is less than 0, it means that your solution is not valid. So these are the boundaries of x that I am going to highlight with a yellow marker now, for which you are able to get the real number. Other than that, you will get the complex number. So these are the restriction for x, you are getting your answers in an accurate way.